This lesson is another really important lesson for being able to efficiently work with equations and graphs in Algebra 1. Ideally, what I would like to do if I were teaching this in a face-to-face class with a classroom of students is I would do an activity where I would want my students to investigate some of the properties of a line. Like I would give them a line to graph and then kind of do a guided exercise where you would discover certain things, because when you're the one that figures it out, the information just sticks better. But that's not really feasible to do in a video. So I'm going to model it, and I might pause at some point and just give you an exercise to do on your own, just to reinforce what I'm about to do. So let's consider this. Well, not that. That was a mess. Let's consider this equation right here. 1/2 x. What do we do? 1/2 x plus 3. Okay? And we're going to build our table with this. And I'm going to pick 0. I always tell my students to pick 0 because zeros are nice. And so if I pick 0 here, you'll notice that 1/2 times 0 is 0, and I'll be left with 3. Okay? Now, this is one of those problems where it's actually, you can pick anything you want. So I'll go ahead and pick a 1 over here. And so we'll have 1/2 times 1, which is 1/2. And then you end up with the fraction plus the integer there. So like with half plus 3 is 3.5. Which is not fantastic, which is 7 halves. And so the 1, while it does work and it does give us a point that's on that line, and we've explored that a couple lessons back, it's not really a great number to use. And so we're going to go ahead with the 2, and oops, there, I didn't mean to do that. There we go. So 1/2 times 2 is 1. And you'll notice that the 2 works better. And with some experience, you would learn that because the denominator of that fraction is a 2, even numbers actually work much better. So I'm going to go ahead and jump up to 4. Half of 4 is 2. And I accidentally hit in my head. I was starting to write a 5. 2 plus 3 is 5. And we'll do one more. All right, and we'll do the 6. So half of 6 is 3, and 3 plus 3 is 6. Okay, so what we've done is we've constructed our table there, and we could go ahead and graph that. Maybe. Let's go see what that looks like. So it's probably going to run into my equation up there. 1, 2, 3. And then I'm going to go over the 2, 1, 2, 3, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6, 6. So right there. And then notice that that point with the fraction in it, that is still on the line. It's 1, and then it's like 3.5, so it's right about there. My line is sitting a little bit too high. Okay, it should be down a little bit. It's just not a great point to graph because you have to estimate where it is. Okay, so what I'm going to do here is we're going to calculate the slope of this line. And we can get it from the graph or from the ordered pairs. And we learned in the last lesson that it doesn't matter which pair of points we pick or which order we subtract them in. The slope of this line is always going to be the same thing. And so let's go take a look at this. If I wanted to go from this point here to this point here, I would go up 1 and over 2. So that rise would be 1 and the run would be 2. And we'll notice that the slope is 1/2. We can also get that from the formula. So I'm going to go ahead and I'm going to use those 2 points. Just I picked a couple points there just for the sake of picking a couple points and for reviewing because you can't review this enough. So let's do 4 minus 6. Over 2 minus 6. So this is -2 over -4. Of course, a negative divided by a negative will give us a positive, and 2 over 4 simplifies to 1/2. Now, the connection that I want you to draw here is that the slope of the line is the coefficient of the x. Okay, I'll say that again. Pause the video, stare at it a little bit, let it sink in, and give your brain a chance to process it. The slope of the line is the coefficient of x. So this is the slope right here. And you can verify that by building the table, plotting the points, counting rise over run, or using the formula. Now, because in math we're really, really big on proving things, just because it happened this one time doesn't necessarily mean it would happen all the time. This might be a weird example. It might be a coincidence. And you always want to ask that question if you see some kind of connection. Like, is that always going to be the case? Well, the fact that I'm doing it in this lesson probably means, like, yeah, it's going to happen all the time. It is always going to be the case. But just for the exercise of it, take a moment on your own and do this one. Okay, pause the video, pick some points for your x's and y's, find the slope, both from the graph and from the formula, and verify that the slope of that line is actually the 3. Pause the video now, work that out on your own, kind of like a in-class activity, and then you can unpause and compare what you have to what I have. All right, here's what I had, and your table might look different. Your line should be the same. You might not have the same dots, but you should have a line in the same place as my line. But your table could be different, and your slope calculation, like whatever you numbers you picked or what order you picked, could be different. But you should have the slope being 3. Whether you counted it from the graph, whether you have the same points or not, or whether you have the exact same numbers going in, you should get a 3 out. And so the conclusion here that we want to draw is that the coefficient of the x is equal to the slope. Now, the other thing we need to talk about is something called the Y-intercept. And this is a really, 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 really important vocab word. So I'm going to star it here. Okay. The Y-intercept. If you follow football, you know, like an interception in football is when you have like the football like going one way, and then the player on the other team comes and catches it, and it's like the point where they intersect, and like it was supposed to get over here, you know, to that guy, and this guy runs and he intercepts the ball. It's called an interception. So the idea of intercepting is crossing. And so the Y-intercept is defined as the point. It is a point. The point where a graph crosses the y-axis. Okay, copy that down, even if you are just, you don't feel like it. The y-intercept is the point where a graph crosses the y-axis. A lot of my students will get confused. They don't think of the y-intercept as being a point. They do think of the y-intercept as being a number. It's not a number, it's a point. So if you have a line, that line at some point, if it crosses the y-axis, that is called the y-intercept. Now, a lot of times we do treat the y-intercept like a number, but you don't want to lose sight of the fact that it is a point. And it is a point on the y-axis where the x-coordinate is 0. Okay? Because we know to locate that point on the y-axis, our x-coordinate would be 0, and then we'd have 0 and then some number. In this case, it looks like, what, negative 1, 2, 3, negative like 3.2 or 3.3 or something. Okay, so that's what the y-intercept is. It is not to be confused with the y-coordinate or the y-axis. So just to make sure we are totally clear on that, okay? This is the y-axis right there. Okay, that's the y-axis. This is a y-intercept because it is the point where a graph is crossing the y-axis. And this is what we call the y-coordinate of a point. And that would be the 3 there, okay? And so y-axis, y-intercept, y-coordinate, I'm aware because I will sometimes give my students like a matching question on this and they'll mismatch them. All right, so here's the deal with the y-intercept. If you have an equation like the first equation we had, which I don't remember what it was, but I think it was something like that. If you plug in x equals 0, this right here drops out because 1/2 times 0 is 0, and you're left with 3. What was the other one? We had y equals 3x minus 4 or something. So again, if you plug in x is equal to 0, then this piece of it drops out and you're left with whatever that number is. Now remember what I just said. The y-intercept always has an x-coordinate of 0. So what we essentially find when we plug in x is 0 is we're finding the y-intercept. And what I want you to note is that the y-intercept is this number here on the outside. So this leads us to what's called y-intercept form of a line, or slope-intercept form of a line. Sorry. Okay, so slope-intercept form of a line. And it is this: y equals m times x plus b, where m is the slope. Okay, and that's what that exercise was, to build the table, look at it, and notice. We did I did an example, hopefully you did your example, that you notice that the coefficient of x, that number in front of the x, is the slope of the line. And when you plug 0 in for x, you are always going to be left over with that b value. So here we plugged in 0 and we got that 3. Here we plugged in 0 and we got the -4, which means that b is the y-intercept. And that's why a lot of students often think of the y-intercept as being a number, because they'll pull it off here and they'll say, oh, the y-intercept is 3 or the y-intercept is -4. Just don't lose sight, and we do that, and that's like not a bad thing to do or anything. It's just don't lose sight of the fact that it isn't actually an ordered pair with an x-coordinate of 0. And so this is where it gets this name, slope-intercept form, and it actually provides us with a really, really quick and easy way to graph lines. So if I have a line and I know where it crosses the y-axis, okay, so that is a fast way to get one of the points, because we know that to graph a line, we need to have 2 points. So if you know the y-intercept, that's a really, really fast point to get. So let's do, we'll do this. We'll do 3/4 x minus 2, okay? So if I plug in x is 0, that's going to drop out, leaving me with a -2. Which means it's going to cross the y-axis right there at -2. So my line goes through that point. Problem is, I don't know how. So like it could go through like this, or like this, or like this. We don't know. We need to have another point. We don't have another point, but we do have the slope, which means we know that the rise over the run is 3/4. So we want to start here, just like we did with every other line, that we've graphed. You start at a point on the line and you count that rise over your run. And so starting here, I'm going to count up 1, 2, 3 and over 1, 2, 3, 4, and I know there must be another point, 1, 2, 3, over there. And that's all I need. Now I have enough to get that line. Now, just to verify it, okay, and this goes back to the definition of what a graph of a line is. Like, all these ideas are connected together. This ended up being the point 4, 1. We know from the definition of what a graph is, if I take this point and I take x is equal to 4, y is equal to 1, and I plug it into that equation, I should get a true statement. So let's just go ahead and check that. So we're going to use y is equal to 1, x is equal to 4. Right here, the 4's cancel out, or you could do 3 times 4 is 12, and 12 divided by 4 is 3, and 3 minus 2 is 1. And again, that like verifies that yes, that point is on the line. We just didn't have to go through the process of building a table to get there. Let's look at a couple more examples of this. So let's do y equals negative 3/5 x plus, I don't know, I'm making these up, plus 6. All right. So I know that this is, that doesn't really look like a 6. Let me see if, there we go. There we go. Looks a little bit more like a 6. So if I were to plug in x equals 0, this would drop out, leaving me with y equals 6. So I'd have 0.06. So I go up 1, 2, 3, 4, 5, 6. So my line goes through that point. This we now know is our slope. And so what I do is I say, okay, well, our rise is -3, which means we're going to count down 3 instead of up 3. And then our run is positive, so we're going to go to the right. So I'm going to count from here, starting right here, down 1, 2, 3, and right 1, 2, 3, 4, 5, and there's my location. 2, 3, 1, 2, 3, 4, 5, right there. Now, just as an interesting side light, and I know I mentioned this in the slope video, sometimes you might end up with your negative in the other position, okay? I just want to show you graphically that doesn't matter. So if you were calculating your slope, building your table, calculating your slope, this would be counting up 3, and then the run would be, for whatever reason, my iPad did not want me to write the 5 there. So just kind of watch what that does. We go up 1, 2, 3, and now we're going to go left 1, 2, 3, 4, 5. And what you should notice there is that it's still on the same line, because what we're trying to generate there is not just a bunch of points, but the graph of a line. And we could like keep going. Like I could start here and go down 1, 2, 3, and then over 1, 2, 3, 4, 5, and it would put me right there, which you can see even freehanding it and having my line be a little bit wobbly, it actually came out pretty good there. Okay, and so that gives us a much quicker way to be able to graph lines. Now, suppose you saw a line that looked like this, or I asked you to graph something, or your teacher asks you to graph something like this, and it says negative x plus 3y equals 6. Now, first of all, you can always build a table, and I really emphasize that to my students. So if you're staring at this and you're like, I don't know what to do, go ahead, pick some numbers, plug them in for x, work out the equation, get the number for y, fill in the table. That will never not work, which is why it's so important to know that you can do it. The other option with this is to do what we call, we call solve for y, okay? Which means get y by itself. And it's so important to know that vocabulary, okay? When the directions say solve for y, that you understand what that means for you to do. So solve for y means get y by itself. So now we have, we kick in from unit 3, the literal equations, that ability to rearrange a formula. So if I want to get the y by itself, I need to get rid of the 3 and I need to deal with the negative x. We're going to start with the negative x by adding x to both sides. Negative x plus x, of course, is 0. And then you could write 6 plus x, But because we're going to try to put this in slope-intercept form, I'm just going to switch the order. That's the commutative property of addition, just switching the order there. And I'm going to do one other thing. I'm going to remind you that there is a coefficient of 1 right there, right in front of that x, okay? It's easy to forget about that. Now, to get the y by itself, you're going to divide by 3, and we want to make sure we divide everything by 3. 3 divided by 3 is 1, leaving us with just y. This, you can, it's going to be 1 times x divided by 3, but you can write it as 1/3 x, okay, that is the same thing. And then 6 divided by 3 is 2. And what we've done is we've done a little bit of algebra to rearrange that equation to put it in slope-intercept form. So here's our intercept. That would be 2, so we can go ahead and plot the 2 on the y-axis. And then looking at that 1/3, we're going to count up 1 and right 3, beginning right here. So up 1 and right 1, 2, 3. And really, if you were to have built that table, okay, and you picked like x equals 0, x equals 1, x equals 2, x equals 3, you would have gotten both of those points, okay, by building your table. And you would have gotten some of them in between that wouldn't have been as nice to plot. All right, so that pretty much sums up how to do the graphs with the slope and the y-intercept. It is super, super useful, but only if you can do it successfully. Common mistakes include when you, usually students can plot the y-intercept okay. Sometimes students will plot the x-intercept instead. They'll plot it on the x-axis. That's not real common, but it's common enough that I thought to mention it. Some students will plot the y-intercept, but then they'll start to count the slope back from the origin. But you don't want to do that. You want to make sure that your slope is counting from the point that you already know is on the line. And the other really common mistake that students make is they interpret the slope as the x-intercept. But we haven't really touched anything with x-intercept, so hopefully that won't be an issue. All right, I'm going to go put some problems on the screen for you to work out on your own. Pause the video, work them out, and then unpause to check. All right, for the first 3, just identify the slope and the y-intercept, and just be careful with number 3 there, okay? Just changing up how it looks. And for 4 through 7, solve those equations for y, or put them in slope-intercept form, okay? And then graph them. So we have, for these ones, y equals negative 2x plus 1, y equals 3x minus 6, y equals negative 4 minus 8x. These ones are 2x minus y minus 3 equals 0, x minus y equals 0, x plus 2y minus 2 equals 0, and 2x plus 3y minus 4, equals x plus 5. Pause the video, work the problems out, and then unpause to check your work. Okay, let's go over them. For the first one, the slope is -2 and the y-intercept is 1. I accept either b equals 1 or the ordered pair, but I know there are some teachers that will want you to write it as the ordered pair so that you don't forget that the y-intercept is a point. For the second one, the slope is 3 and the y-intercept is -6. Please don't forget that there's a -6 there, so or 0, -6. Now, sometimes we can get so kind of inattentive that we're not really paying attention to the order that things are written in. So this one is actually not quite in the right form. It is the coefficient of the x that is the slope, not necessarily the first number that you see. So if somebody pulls a fast one on you and switches the order, you want to be attentive to that. So in this one, the slope is the -8 and the y-intercept is the -4 or 0, -4. For this one, and as with all of these, if, as always, pause it and let yourself catch up. Okay, for this one, to solve it for y, you might have done it differently, but I opted to add y. I just thought the easiest way to get the y by itself was to go and kick the y over to the right-hand side. So -y plus y is 0, leaving me with 2x minus 3. And so I have 2x minus 3 equals y, and then I just use what's called the symmetry or symmetric property of equality to switch the order of that, so y equals 2x minus 3. Sometimes when first starting with these, students do have a little trouble with this because they don't see the denominator. So remember that the denominator on that integer is a 1, and that goes all the way back to the beginning of this algebra sequence where we talk about what a rational number is, and a rational number can be written as a fraction. Usually, if we have a beautiful 2, we don't want to write it as a fraction, but in this case we do. So we can plot the negative 3, and then for the slope, I will count up 2 and write 1. Next problem. I did the same thing here where I added y to both sides to get x equals y and then switched it. So this one, again, and you shouldn't ever leave it blank. Ever leave it blank. Like if you totally run out of steam, set up your table, pick a value for x, find the value for y, and plot those points. So if you did run into a little bit of an issue with this one because it looks different, remember that the coefficient of the x is a 1. So we don't normally write 1x, but we could. And then that number that's being added is the 0. So this is really 1x plus 0. So the y-intercept was 0, and then the slope was 1, which you could write as 1 over 1 if you needed to. So we go up 1 over 1. Like so. If you got the correct line, that's the real important part there. Not that all of your work matches mine exactly. Okay, for this one, I started by subtracting the x, and I actually did the next problem differently, but I subtracted the x. 0 minus x is negative x. And then I went and added the 2, so like x minus x is 0, leaving me with 2y minus 2. Added the 2 to both sides, and I did that so that my addition would be in the most natural order, so I'd have like the negative x plus 2. Now I put in this like 1 right here, kind of like I did over there. You just might have to remind yourself that there is a 1 there. Then divided everything by 2. 2 divided by 2 is 1. The slope ends up being negative 1/2, and then 2 divided by 2 is 1. So my y-intercept is 1, and then my slope is negative 1 over 2. So I count down and then right. I usually like my students, because our lines can wobble a little bit, that they put the dots there just so that like mine kind of got off a little bit there. Like I would know that a student meant to put the line in the right spot. For this one, I don't know why I did this one differently, but I did do it differently. I added the 4 first. So negative 4 plus 4 cancels out, and then 4 plus 5 is 9. Then I subtracted the 2x. So 2x minus 2x is 0, leaving me with the 3y. 1x minus 2x is negative 1x. And then divided everything by 3 to get y equals negative 1/3 x, and then 9 divided by 3 is 3. So my y-intercept is 3, my slope is negative 1 over 3, so I count down and then to the right. All right, that was a lot of information in one lesson, and it's another long video. It's the third long video in a row, sorry. But it's really that important. So bookmark it, watch it again, rewind it, do what you need to do some extra practice problems in order to make sure that this concept sticks. And I'll see you in the next video.